Namaste everyone, hope you are doing well. So we will continue that ray optics part. Today we will have a discussion on how a concave mirror forms image and also convex mirror forms image when the object is kept at different distances. Now if you take a concave mirror and so this is a larger concave mirror I have taken today. If you place an object very close to it, can you see the enlarged image of this object at certain distance? So you can see the image at one position, the enlarged image, right, inside the mirror, right? So you can see the enlarged image inside the mirror. For certain object position you can see this. And now suppose so this is one type of image. So you can see the image when the object is at a certain position inside the mirror, but you don't see the image inside the mirror in a concave mirror always. Now suppose if I hold object and if the object is outside the window, right? If the object is outside the window and if I hold the mirror and try to get an image. Yesterday we did this in the previous class. Okay, I will take a little bit more light. I will come to this side. Let us try this here. So when you take an object here, you see this is a different type of image. You can see the image of the window and trees. Yeah, you can see the image of the window and the trees. Outside the window, coconut trees, but they are inverted positions. You can see a small building, right? By holding this it is difficult to focus it, but still you can see something. So this is another image formation. Of course this image can be caught on a screen, whereas the last one, when I held a chalk piece in front of the mirror like this, and you can hold this mirror in front of your face. When you bring this mirror very close to your face, you can see the enlarged image. So how all these types of images are formed? So depending on the position of the object, concave mirror will form images at different positions. That's what you have to do now. So please be ready with a paper and a pen. I always say this, without paper and pen, don't watch this movie. You should keep on writing the dialogues and all the scripts, so you must be along with me. Simply it should not be a film matching process, then you will keep on sleeping. So if you want to avoid it, have a pen and paper and start writing. So be ready with pen and paper. Okay, first of all we will remind what we have seen in a concave mirror in the previous classes. One is suppose you take a concave mirror. See how do I take a concave mirror? I always give the opportunity for the light to travel from left side to right side. That means in the positive x-axis like this, right? Light travels in this, because if I keep an object here, definitely the light travels from left to right. And if you incident parallel rays of light to a concave mirror, after reflection they pass through a point called focus. And if I complete this sphere, it is a part of a sphere. If I complete this sphere, there is a center like this. So where we have to keep the object, sir? You can keep the object anywhere. We will start keeping it from different places. Now, hope you are writing along with me. So you have to draw this. You have to be ready with the mirror. Suppose this is the pole. Now we will write object position. Object at infinity. We will take. What do you mean by object at infinity? That's what I have shown that experiment. I have focused, or I have kept the mirror in front of a very far away object, and I try to get image on a white screen, and I got an image on the white screen. Very small image. Those coconut trees were looking very small. Okay. Now, how that image is formed? Very simple. The rays of light coming from a very distant object can be taken as almost parallel. So when parallel rays come from the very distant object like this, we know that they meet at focus like this. So this is highly diminished image, very, very small image. So compared to the size of the coconut tree, that image was very, very small. So it is highly diminished image, and it was inverted. All the coconut trees were found inverted. So when the object is at infinity, image is at F, focus. Image is formed at focus because parallel rays come from infinity. For an object at a very large distance, parallel rays are emitted and they meet at focus. Image is at F, and image nature is real, because really the rays of light meet, and inverted and highly diminished because it is very, very small, highly diminished. And you can do this experiment. Take a concave mirror and hold it in front of the sun. Sun is at very large distance, and light rays coming from the sun are almost parallel. Hold the mirror in front of sun and try to focus the rays of light on the wall. You will get a point object, very small focused point, very bright point. All the rays go and meet at that point, and that point is called focus. So if you are given a sentence like this: a student is holding a concave mirror in front of sun and he was able to focus the rays at a distance of 30 centimeter on a wall. What is the focal length of the mirror? Definitely, focal length of that mirror should be 30 centimeters, because when parallel rays are made to fall on the mirror, all of them meet at this point. And if this is the wall where the rays get focused, if this is 30 centimeter, definitely it is focal length. So you can find out the focal length of any mirror by doing that experiment. Hold it in front of sun, make the rays to focus on the wall, adjust the mirror, and when the rays get focused on the wall, the distance between the mirror and the wall is the focal length. And if you double it, you know, r equal to 2f, you get the radius. So 60 centimeter will be the radius of curvature if 30 is the focal length. Okay, and it will be highly diminished. So that point image is the image of the sun, very highly diminished and real. So real inverted highly diminished image is formed at the focus. Okay, this is one condition and we know it. Suppose, so we have used it in our daily life. We play with this concave mirror like that. And suppose the object itself is at focus. What will happen? I will take a concave mirror and I will keep the object at the focus itself. Right? Concave mirror, keep on drawing it. Object at focus. Yeah. So I will keep a bulb here. I will keep a bulb, source of light, so that rays of light come from the focus itself. So I will keep it on the focus. So when you keep a bulb at the focus, and here you have at the double distance center, rays of light parallel to the principal axis always pass through focus. Any ray of light passing through the focus should become parallel. We know that. It is the principle of reversibility. Light follows the same path if it is made to come back. So if the bulb itself is on the focus, how do the rays move away? They move away and hit the mirror, they should become parallel. So any ray of light coming from the focus should become parallel after reflection from the concave mirror. So they become parallel. So you will get a parallel beam of light. So using concave mirror, you can produce a parallel beam of light from a diverging light source. If you have a bulb, light rays are diverging from the bulb. But if you keep the bulb at the focus of the concave mirror, the rays of light after passing through the focus and they become parallel. This principle is used in the headlight reflectors in vehicles. In vehicles we have a bulb which is actually diverging, which is a source of diverging light. That concave reflector or some parabolic reflector which is concave in shape will be kept behind the bulb, and the bulb is exactly kept at the focus, so that light rays coming from the bulb will become parallel, and all the light rays which were ready to go away and scatter around are strictly made to come parallel, and only the rays of light are focused to the road. Because when you drive a vehicle, you need not have light on other sides. You want the light to be focused on the road only, because you need to have only vision on the road. So this is what we do in headlight reflectors. So headlight reflectors contain a bulb which is exactly on the focus, so light coming from the focus become parallel. Of course, this principle I have forgotten. So this principle is used in that to receive the signals from the satellites, we use some antennas, dish-like arrangements like this. So we have a dish-like arrangement in our house, like kept like this, and here is a collector instrument, and all the signals, video signals, will be coming from the satellite, which is at a very large distance from the antenna or this dish, and this is like a parabolic reflector like this, and all these radiations coming and falling on this parabolic or concave shaped reflector, they get reflected, and this is exactly kept at focus, and they meet at focus, and this will be collected and it will be fed to the TV. All the signals will be made to focus at the focus, where exactly that collector of video signals will be kept, and then it will be collected, sent to the TV. So this is the principle here, same principle. Of course, there we don't use visible light, we use video signals. But video signals have all the properties of light, except that it is not visible to human eye, that's all. Okay, so this is the principle. When the object is at F, image is at infinity, and it is highly enlarged, because we don't know when they meet. By the time they meet, they might have traveled a very large distance, and image is highly enlarged, real and inverted. Okay, very, very large image. Okay, so that is one thing. So when the object is at focus, image is at infinity, very large distance. Now, better you understand it by remembering the applications form. Object at infinity, this antenna dish, object at focus, image at infinity, they are becoming parallel. That is a headlight reflector. Okay, now the third one we will see. Object not at infinity, we will bring it a little bit closer, that is beyond C. Object beyond C, center. So let us keep an object beyond the center of curvature. So we will take a concave mirror like this, and right, this is the focus where parallel rays meet, and this is the center. Let us keep an object away from the center. This is the object. In order to identify it, I will have an arrow mark. So this is B and this is A. Yesterday we have drawn, or in the previous class we have drawn this in order to find the relation between focal length, object distance, image distance, etc. Okay, now where is the image? You have to consider at least two rays coming from one point of the object, and if you can trace the image of one point, of course you will be successful in getting the remaining part of the image. So consider two rays of light. One ray passing parallel to the principal axis, like this. Let it pass parallel to, because we are very much knowing about this ray. After reflection, it passes through focus. So we know this one. So two arrows, every time you should have arrow. As soon as the ray of light gets reflected, you should have an arrow. Now let me consider another ray of light which is incident. Of course you can pass it through center also, that is also possible. Pass a ray of light through the center, it gets reflected back in the same path, that is also possible. But we will follow the ray which is in the NCERT syllabus, so that you can write the same answer in the exam also. Make a ray of light to fall onto the pole at some angle. Of course this is the angle of incidence. You know that this itself acts like a normal, because this is a line which is passing through the center at this point here, like this. So this ray is incident at an angle of incidence I, and it should pass such that the angle of reflection is also same. So it should pass like this with the same angle of reflection, and it should proceed. So like this. Now the two friends, starting from the same point, carrying the information, after reflection they met once again. They should reproduce this. So this is this part of the object, and this is the image, and B dash and A dash. Right, A dash, B dash is the image. Here only two rays are enough. But while drawing the diagram for deriving 1 by f equal to 1 by u plus 1 by v, we considered one more ray which is passing through the center, but that is not needed now. So when the object is beyond C, how is the image? Where is the image? We will have to describe the type of image. When the object is beyond C, image is, okay, image is between F and C. You can see that. Between F and C. And it is real because the rays of light actually meet. They actually meet here. So real, inverted. So real, inverted, diminished. It is smaller in size. So real, inverted, diminished image is formed between F and C. Focus and center, right? So when the object is beyond C, image is between F and C, and it is real, inverted and diminished. Okay. Now we will go for an object at C. We will bring it. So we were at infinity, far away. We brought it towards and we brought it up to a distance which is close to C. Now we will keep it at C. So if an object is kept at C, object at C, at the center. Okay, take a concave mirror, draw a principal axis, pole is the geometric center, and we have a focus where parallel rays meet and center of the whole curvature C. Now keep an object at C like this. So AB is an object kept at C now, A and B, at the center itself. As usual, we will consider two rays of light. One ray parallel to the principal axis, after reflection passes through focus. I must be very careful now because I should get the image at a particular place. Okay, like this. A ray of light moving parallel to the principal axis after reflection passes through focus. Another ray incident to the pole like this. After reflection, it should reflect with the same angle and it should come here. So I know where should be the image formed. That's why I am trying to correct it. So it should be geometrically proper, or I'll do it like this. This is a better option. So it gets reflected like this. Right. So I will write C here, and this is the image at C only. So when the object is kept at C, image is also formed at C, because this is focus. When the object is kept at C, image is at C. How is the image? It is same sized, inverted and real. It should be of same size. That's why I was struggling to get these rays to meet here. Somehow I have to get it because I don't have scale. I can't write it properly. Somehow you have to make it here to meet. So we have finally got it that the image is formed at C and it is of same size. So image is at C, and okay, it is real, same sized and inverted, right? So when the object is at center, image is also at the center, same sized, real and inverted, and only concave mirror can form these images. And all these image formations, we are going to list it, but you need not by heart that table at all, because each image formation is a peculiar one. It has a particular application. When the object is at infinity, image is at focus. We know that is the principle of parabolic antennas which collect the video signal. When the object is at focus, image is at infinity. It is the reverse case. Object and image change their positions, right? It is a reverse case, and that is a reflector of the headlight of vehicles. Okay, now when the object is beyond C, image is between F and C, right? When the object is at C, image is also at C. This is a particular case. No, except a plane mirror, no, or even if you leave plane mirror, if you consider plane mirror, no mirror can, or no other mirrors produce image, real image of the same size when the object is kept at a certain distance from it. Only concave mirror can produce. Other than concave mirror, we don't have any other mirror. Only concave mirror can produce real, inverted and image of the same size. Sir, won't plane mirror produce the image of the same size? But it is not real, it is virtual. If virtual image of the same size is produced, then it is from the plane mirror. If real image of same size is produced, then it is by the concave mirror, and especially when the object is kept at center. So this you have to remember always. For example, the problem is asked like this theoretically. A boy holds a concave mirror in front of a candle flame, and he finds that the image of the candle flame is formed at the same place, inverted, of the same size. And distance between the flame and the candle is 20 centimeters. What is the focal length of the concave mirror? So a student is holding this candle flame in front of the concave mirror, and he finds the image, inverted image, by holding a screen here, inverted image on the same place and of the same size. If the distance is 20, it should be radius. This should be radius of curvature, because it is the only position in the concave mirror where we get the same sized image. So at the center, a same sized image is formed, and now if this is 20, focal length is 10. So you must know the theory behind it. Okay, that is another condition. When the object is at C, image is at C only. Now you get the reverse of all the cases. Now we will keep the object between F and C here. So if the object is kept between F and C, okay, object between F and C, okay, concave mirror, you have to draw this along with me. Pole, hope you are doing so, focus, center. If you are not taking any paper and pen, and if you are not writing these things, it is a waste, no use at all. Just take a paper and pen, keep on writing whatever I do. You need not write the sentences. Sentences you will get anywhere in the book. Understand the theory behind this, understand the gist of this. Then you can do anything, right? So you can write the things related to that once you understand the theory behind it. Okay, let us keep an object between F and C here, anywhere between F and C. Again the story goes the same way. Object, okay, here I didn't mark the image. This is B dash, this is A dash. Here this is B, this is A. So same story. Take a ray of light, incident parallel to the principal axis, like this. After reflection it passes through focus, like this. Okay, I'll shift the focus. Instead of rubbing such a long line, I'll shift the focus. That is easier. So a ray of light incident along the parallel to the principal axis passes through focus. Consider one more ray of light. A ray of light incident to the pole at some angle of incidence. After reflection, it moves like this. Oh, this is not a straight line. It should be a ray of light. Okay, so it moves straight like this. This is the focus and reflected ray. So arrow mark, 4 arrow marks. Incident ray, after reflection, coming like this. Okay, I can draw the arrow here. And another incident ray to the pole, after reflection, coming like this. So where is the image now? Image is formed here. This is B dash, this is A dash. So the same rays of light, 2 rays of light. So a ray of light, incident parallel to the principal axis, passes through the focus, another to the pole, reflects in such a way that it meets the previous ray, and both of them form the image here. So what type of image? Image is beyond C. Image is beyond C, and it is real, inverted and enlarged. Real, inverted and enlarged image is formed beyond C. Now compare this case and this case. Object between F and C here. Sorry, here, beyond C. Object between F and C and beyond C. Compare the two cases. They are quite reversed. When the object is beyond C, image is between F and C, real, inverted, diminished. In that case, when the object is beyond object is between F and C, image is beyond C, real, inverted and enlarged. One thing you remember here, whatever is between F and C, it is smaller. What is here between F and C? Between F and C here is the image, smaller than the object. Here between F and C it is object, smaller, image is larger. Whatever is beyond C, it is larger. Here beyond C is the object, larger than the image. Here beyond C is the image, which is larger. So you remember always this concept. Whatever is beyond C, it is enlarged. Whether it is image or object. Whatever is between F and C, it should be diminished. Whether it is object or image. So between F and C, everything is diminished. Beyond C, whatever you get, it should be enlarged. Beyond C, image enlarged. Beyond C, object enlarged. Between F and C, object small. Between F and C, image small. So it is just opposite cases. So all that table, when the object is kept beyond C, at F, at infinity, you have some 5 to 6 different possible cases. But you need not remember it. Theoretically go to the points. When the object is at infinity, parallel rays, image is at focus. Real. And all the images are real, you see. Everything is real. And really the rays of light meet. Okay, object at focus, image at infinity. And object beyond C, image between F and C. And all are inverted, real images. And object between F and C, image is beyond C. Beyond C larger, F and C between F and C, it is smaller. Whatever it is, object or image. So the whole thing gets squeezed, the whole table gets squeezed. And all possible cases. So now is a peculiar case. Last time I have shown a concave mirror with a pen or something is kept in front of it. When I keep that pen very, very close to the mirror, and when the pen is away from the mirror, you don't see anything inside the mirror. Now you can't see anything inside the mirror, but when the pen is very, very close to the mirror, you can see the enlarged image of the pen or a chalk. You can see the enlarged image of the chalk, right? So you can see this now. Now this is the special case, and this is the only position where you can see the image inside the mirror. You can see the image inside the mirror. Okay, so what is this special case? Sir, then what about all these images? Are they not produced inside the mirror? Never, they are not produced inside the mirror. You have to place a screen in front of the mirror so that you will get the image. So for all these things, to catch the real images, you need a screen. Because if this point of the object has to be seen again, you should give an opportunity for these rays to meet at a point. You place a screen here, you will get the image, as if you are holding some white paper, white screen. So real images are formed on the screen. Right. Now, what is that particular case where image is virtual? Object between F and P, pole. Object between F and P. This is the special case in a concave mirror. Of course, everything is special. Everything has its own significance. But this is very, very special. What is the use of this? Say focus, geometric center is called pole. Every time I say the definition, so that when you repeat it 5 or 10 times, it gets printed permanently. C, center, right? So along with understanding the things, we must go how to reproduce it in the examination. That is also very important. How to remember it for the examination. Okay, so this is the center, focus, pole. This is the point where parallel rays meet. This is the center of the whole curvature. Okay, now let us keep an object within the focus. Let us bring a chalk very close to the mirror. What happens? Again, as usual, you have to go for the same story. One ray of light passing parallel to the principal axis from A, I have to name it A, moves parallel to the focus like this, right? So a ray of light incident parallel to the principal axis after reflection passes through the focus, and another ray of light incident to the pole after reflection, it moves like this with the same angle of reflection here. Angle of incidence and reflection will be same. Of course, the rays of light are not exactly straight lines. You have to somehow assume that they are straight lines now, because I will try to write straight lines as far as possible. A ray of light incident parallel to the principal axis after reflection passes through focus. Another ray incident on the pole at an angle of incidence I gets reflected in the same angle. Of course, just as you, according to your convenience, you say that it is you need not have a compass and measure it, whether it is the same angle of incidence or reflection. Just eye measurement is enough. Okay, now, do these two rays meet? What about here? They were converging and meeting here. They were converging and meeting here. The rays of light were meeting here every time, here, here. But what about here? They never meet. They are diverging. They are moving away. You ask these two rays, where are you going? Are you going to form the image? No, sir. We are diverging. We will never form the image. We are never going to meet. And you suppose you look from this point. You feel that this is your eye. My beautiful diagram. Okay, I think you can follow that this is the eye. Okay, for a person observing from here, he feels that these two rays are not coming from this object, AB. They are coming from some point here. Produce this backwards using the same straight line, right? Produce this backwards. He feels that these two rays, the ray which is coming like this diverging, ray which is coming like this diverging, he feels that these rays are coming from a point here. So this point appears to be the image. Again dotted lines I put, because this is a virtual image. Rays really they come from here. They don't come from here. They appear to diverge from this point, and this point becomes the image, A dash B dash, and we call it as virtual. That is what we have seen. An enlarged virtual image is formed inside the mirror. That is possible only when you bring the object within F and P, not away from F. This is the only case where the image is formed within the mirror. You need not have to have one more screen to catch this image. You can see this inside the mirror itself. So, one ray parallel moves to the focus, another ray incident on the pole at some angle gets reflected like this. They never meet as we got it in the earlier cases. They never meet, they diverge. So, but for a person observing from here, it looks as if they are coming from here. This is the virtual image. So, object between focus and pole. What about image? Image is virtual and erect, because you have the candle flame here, image flame here at the same place. Virtual, erect and enlarged image is formed. Enlarged image. So where is the position? Inside the mirror. Inside the mirror or on the other side of the mirror, other side of the object where it is kept in this side, other side we have the image. So virtual, enlarged image, erect image, image is formed inside the mirror. This is the only case when a concave mirror forms the virtual image, and in no other cases it forms the virtual image. So see, everything is peculiar. I had told a plane mirror forms virtual image, but it is always of same size. A concave mirror forms virtual image, it is always enlarged. This is the speciality. Suppose you want to view the image of an object very enlarged inside something, best choice is concave mirror. That is why concave mirror is usually used by dentists. It is used as a shaving mirror, because if a person wants to shave, he can use a concave mirror. When his face is very close to it, he can see his beautiful face and he can shave very nicely. Of course, it is used in all types of beauty parlors also. So ladies will use this, and you can get the enlarged image of the face. It is especially used by dentists. See, if you go to a dentist, dentists use concave mirror. So you remember this application, it will become very easy. Dentists will have this type of arrangement. We think that this arrangement is used to remove the teeth. Suppose you have some problem in your teeth, and if you are feeling pained, you go to the doctor, and doctor will ask you to lie on a very long chair, and by looking at the chair itself you get frightened, but still you will lie on the chair, and it will be like a sleeping position, and doctor will ask you to show which is the paining teeth. Then he will put this inside your mouth. You feel as if he has started removing your teeth, but actually he doesn't do that. He will check it. So what he will do is, he will bring this mirror, and here is a mirror, and it is a concave mirror. He will bring this mirror very close to your teeth. Of course, here I can't show the image. Of course, teeth can't be brought, object cannot be brought nearer the mirror. you have to bring the mirror near. However, it is already paining, you can't touch it at all. So bring the mirror closer to the teeth. When the mirror is brought closer to the teeth, so that teeth lies within the focus, you will get the enlarged image of your teeth inside the mirror, and doctor can see the image inside the concave mirror, and that image is enlarged, and everything what has happened to the teeth will come out, and he will come to know about all those things. So that helps us. So now you can have the questions, sir, can't he use a plane mirror here? What is the use of using a plane mirror? No advantage of using plane mirror, no advantages. If you use a plane mirror, you will see the image of the teeth as large as the teeth only, because it forms the same sized image. Instead of that, you can look into the teeth itself. You need not look into the image, right? So no use. Concave mirror is the best choice. So if you want to remember this position or this condition, this is used by dentists and also as a shaving mirror or decorating mirror for the face. And of course, only you look into the image in the mirror, you don't decorate the mirror. For decorating the face, you can use this mirror. And a dentist mirror. So since, and if you are asked why dentists use concave mirror, because if you place an object within the focus of the concave mirror, it forms enlarged virtual image. That is why dentists use this, and that image helps them to check the teeth, problems with the teeth. Okay. So every image formation is having its own significance. You need not by heart that table at all. Now all the tables should be in your brain. We will recall it. Don't look into the diagrams, just we will recall it. Object at infinity, parallel rays will come. They will meet at the focus. Real image at the focus, highly diminished and inverted. Real images, first real images are always inverted. First image, real image is always inverted. Object at focus. From the focus, rays after reflection should become parallel. Image at infinity. So these two are the cases which are one contrary to the other. Object at infinity, image at focus. Object at focus, image at infinity. At infinity, it is enlarged image. If the image is formed at focus, it is highly diminished. Okay, one contrary case is over. Object beyond C. I have already told whatever is beyond C, it should be enlarged, right? Object beyond C. Image is between F and C, inverted, real, smaller size. Object between F and C, focus and center. When the object is between F and C, image is beyond C and it is enlarged, inverted, real. Inverted real is common now. So when the object is between focus and center, image is formed beyond the center, image is enlarged, inverted, real. At C, okay, you are coming to the junction. Away from C, between F and C or within C, at C. At C, when the object is at C, image is also at C, at the center, and image is of the same size. And this is the only mirror which forms a real image of the same size. No other mirror forms real image of the same size. So at C, real, inverted, and of the same size. Okay. Then the last one, very important one, dentist mirror. When the object is within the focus, in front of the mirror, that means pole and focus. And an erect, enlarged image is formed within the mirror. That's why it is used by, and it is virtual image, that's why it is used by dentists. So everything is squeezed to a small package, and most of the cases are, you can club the two cases, one reverse the other, so that becomes easier. So you go home and okay, you need not go home, you are in home only now. So you open that NCERT book, see that table. You will find that all these things, possible cases are written, but you need not by heart it. You can just remember technically and the positions of the images. Now we will go for convex mirror. How will be the image formed by the convex mirror? Convex mirror is a special type of mirror. It also forms virtual image, but it forms the diminished image. Best example, rear view mirror. Go to any vehicle, see the driver mirror used by the driver to view the rarer objects which are coming from the back side. That mirror is bulged from outside, from where it reflects. and it always forms diminished virtual image. And you have to give special thanks to convex mirror. Do you ask me why? Concave mirror forms so many types of images, but convex mirror forms only one type of image. What is that? So shall we discuss it now? Then we will go to the next part. Convex mirror, I have to keep the mirror like this. Reflecting part always towards my left side, so that I give opportunity for the ray of light to come from left to right. Okay. Now, where are the pole centers? You see, in a concave mirror, you got the chance of putting the objects away from C, at C, between F and C. Now, in front of the mirror, you don't have C, you don't have F, all the things come inside the mirror, because you know that if parallel rays are incident on a convex mirror, they diverge as if they are coming from the focus. So, focus is here, center is here. If you complete this sphere, you will get a center here. So all of them come here. So there is no question of placing the object here, 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 because you don't go behind the mirror and decorate yourself. You should stand in front of the mirror. So in front of the mirror, you have to keep an object. Sir, where we will place? Any position, because there is no particular position, there is a name for a particular position. There is no name. Keep an object here. Let us take a little enlarged object, because I know that I will get a diminished image. Okay. Take two rays of light, one parallel to the principal axis. After reflection passes through focus in a concave mirror. Here appear to diverge from focus. Any ray of light passing parallel to the principal axis. So before getting reflected, you just confirm that this is a line which is towards the focus. Otherwise, simply reflecting it somewhere else and trying to bring it towards the focus doesn't look nice. Now it should reflect in this direction only. Correct? First you join this and see how does it get reflected. So a ray of light parallel to the principal axis after reflection diverges in such a way that it appears to diverge from the focus. Take one more ray of light passing to the pole and moving with the same angle of reflection. Angle of incidence, angle of reflection. As if you have considered in the other cases. Same thing here. So incident ray diverging such a way that coming from the focus, appearing to come from the focus. Another ray incident on the pole getting reflected in the same angle. Now you ask these two rays, are you going to meet? No sir, as we had here, they are diverging in such a way that they will never meet. But for a person observing from here, if he receives these two rays, he feels that this ray and this ray are just projecting out from here, from this point. So he feels that this ray is coming from this point source, this ray is coming from this point source. So he feels that the flame part of the candle is here, and of course it is virtual, and this is the image formed, and this is A dash, B dash. This is the image formed here. So virtual and diminished image is formed because rays do not actually meet, they appear to meet here at this point. So since they started from here, this should be the image part here. Okay? Yes. Right. So in convex mirror, wherever is object, you keep it here, here or here, for any position of object. For any position of object, image is inside the mirror. Of course, it will be within the focus. Inside the mirror, it will be within the focus, because only when you take the object at infinity, you will get image at the focus. Image is inside the mirror, virtual, because rays do not meet actually, erect, and diminished. It is smaller in size. Virtual, erect, and diminished. So this is the special case of convex mirror. Sir, because of this special case, whether convex mirror is used anywhere? Yes, it is a rare view mirror in vehicles. Rare view mirror in vehicles. What is rarer side? Rarer side is the one which we can't see. If you are driving a vehicle, if something is coming from back, you must be able to identify what is coming from back because you want to give the side. Sir, it is a diminished image formed. Doesn't it produce any problem? No, not at all, because if you can see the smaller sized image of a bus, you know what is the actual size of the bus, because that is not the first time you are looking at a bus. You have seen bus so many times. So just identifying the object is enough for us. So, and sir, why can't we use concave mirror as a rear view mirror? Why can't you use concave mirror as a rear view mirror? Problem is, in a concave mirror, inside the mirror, image is formed only when object comes within the focus. So if the driver is using a concave mirror as a rear view mirror, ask him, why are you using concave mirror? Because I can see enlarged image of the object. I can see it very clearly. But the problem is, if something is coming from backside, he will be able to notice it inside the mirror only when that object enters within the focus. Suddenly he will be able to see the image. And as far as the object is away from the focus, he will not be able to identify it. Because in all the cases beyond the focus, image is formed real. It is not formed inside the mirror. Only when the object is within the focus, image is formed inside the mirror. So all of a sudden he will come to know that an object is coming from back. And after that, there is no time for adjustment. So there may be a chance of accident occurring. So in order to avoid it, we use convex mirror. Sir, what is the advantage of convex mirror? Wherever is the object, we get image inside the mirror. Always it is formed. Whether the bus is coming from a very long distance from your backside, whether it is very close, image is formed inside the convex mirror. You may be able to identify all the objects. And moreover, convex mirror is bulged outside. Its field of view is more. What do you mean by field of view? It can cover objects in a larger space. So when you have a small convex mirror as rear view mirror, it is enough to show all the world behind it. So it has two advantages. It can cover all the view, it has more field of view, as well as it can give the image of any object at any distance from it. But image is diminished, no problem. Even if the image is diminished, because we are looking into the images of the objects which we have already seen. So in reality, how much larger it is, we know it. So that's why it is used as a rear view mirror in vehicles. And of course, can dentists use this? No use, because if dentists use a convex mirror, wherever they hold, even outside the mouth, they can see the teeth, but diminished image of the teeth. That doesn't help us. So this is a particular case. But thank convex mirror that it forms only one diagram. So if you are asked to write a ray diagram for producing different types of images, then this is the only case for convex mirror. But for a concave mirror, they may ask you, draw a ray diagram showing an enlarged image, real image in a concave mirror. If you want to draw the enlarged real image for a concave mirror, you have to keep an object between F and C, isn't it? You have to keep the object between F and C. Right? And draw a ray diagram for a concave mirror showing the image which is which is virtual and direct. You have to draw this diagram. So you have to go for a particular case. But in such cases don't exist in convex mirror. So it forms always forms real and virtual, diminished, erect image. And virtual images are always erect. Remember, first images are always erect. So that's about the formation of image. So this may be a question for the examination, and this idea, all the types of images, image formation, that idea is very, very important while you solve the problems. You must know that answer should be like this and like that. So you should tag it wherever you want. So you should bring all those ideas when you solve the problem. I got this answer. Whether this answer is correct, whether that image formation is proper according to this theory. If you know it, you can solve the problems. So before going to the problems, we will take a break. Thank you. Keep writing this, keep drawing this, have a very good idea of all these things. Don't simply just leave this as it is. Practice it yourself. See why the rays are going like this. What is the reason behind this? Keep practicing. Thank you. Yes. Now, we have seen different types of image formation in a concave mirror as well as convex mirror, which is only one type. Now, we will put into a problem, because in this chapter, Using the sign conventions is very important. And in the previous class we have seen how do you take the sign conventions. That is theoretical part, how to apply it. And when the real part comes into picture, you should be extremely careful. Now I don't give you a problem, we will analyze some numbers and then we will go to the problem. Now I will take a concave mirror of focal length 20 centimeters and find the nature and position of the image for different positions of object. Already we have seen when the object is kept beyond C, image is between F and C. When the object is between F and C, image is beyond C. And when the object is at C, image is at C. And when the object is within the focus, enlarged, virtual, erect image. All these things are we know it now properly. Now, so whether these images will be obtained using the formula, is it possible? So we will analyze it so that once you solve this yourself, then you can solve the problems. Now let us see the object distance. Before that, we will be let us make very firm with our formula. What are the formulas used? Mirror formula: 1 by F is equal to 1 by U plus 1 by V. And another thing is magnification. Magnification is height of the image by height of the object, which is also equal to minus V by U. V is image distance, U is object distance. Now we will come to this position. Object beyond C, image is between F and C, and image is inverted, real, smaller. You know that technique of remembering. Anything beyond C is larger, anything between F and C is smaller. So now we are getting image between F and C, smaller, object beyond C, larger, right. Now I will give you, okay, we will solve this condition. So magnification formula h dash by h is equal to minus V by U. We have a minus here, we don't have minus in the mirror formula. Let the object distance be, okay, I'll write it here only. Let the object distance U be, so we have to go beyond C. Center will be at 40 centimeter because this is radius, this is focal length. Double the focal length, we have radius, and object distance, say this is 40, say 50 centimeters. Let the object be kept at 50 centimeter, which comes to be beyond C, right? So we should get this case. Do we get that case? Now, in a concave mirror, when parallel rays are incident on a concave mirror, like this, if parallel rays are incident on a concave mirror, after reflection they meet at focus, and this is called focal length. Now divide this into Cartesian coordinate system. Everything that comes in the right hand side is positive, everything that comes in the left hand side is negative. Everything above the principal axis is positive, below the principal axis is negative, provided if the ray of light is moving in the plus x-axis direction, like this. That's why we have kept the mirror like this. That's why I ask always you to keep the mirror such that the ray is going in the plus x-axis. So now focal length, all the distances are measured from the pole. Focal length comes on the left hand side, negative. Center will be here because this is the part of a sphere. Center will be somewhere here. Of course, if this is the focus, this is the center. Radius is negative for a concave mirror. So if I write the radius, so focal length, strictly it is minus 20 centimeters. And if I write the radius, it is minus 40 centimeters because r is equal to 2f. So every time when you substitute the formula, when you get the answer, plus, minus, whether it is proper or not, you have to go on checking. So let us do it with a lot of patience. So radius is negative, left side, focal length is negative, left side. Okay, now we will keep an object at a distance of 50 centimeter. When you keep an object at a distance of 50 centimeter, you have to keep it like this. Okay, this is the coordinate system, this is the silvered face, and object should be kept here, again left side. So U is negative. They will say in the problem it will be given, keep an object is kept at a distance of 50 centimeter from a concave mirror. They won't mention whether it is plus or minus. You have to take it because it is a convention. Okay, it is minus 50. Now where you should get the image, let us analyze it in the beginning and then we will try to get the answer. Image should be between C and F. That means our answer, image distance answer, should be between 40 and 20. Am I right? It should be between 20 and 40. Let us see whether we get it as between 20 and 40. So you should do this. Again, I remind you, you should have a pen and paper and you have to write all these things. Without writing, better you go out and do your own job. Otherwise, it is useless, right? Take a pen and paper, start writing all these things. So analyze it. Of course, these things you have already written, you need not write it again. I have kept it on the board for the reason that I can compare it, that's all. But you have all these things in your mind. I am very sure you have understood all these things and you have that things in your brain. And now, yes, our image should come between 20 and 40. We will check whether we will get it or not. We will apply the formula 1 by f equal to 1 by u plus 1 by v. That implies, keep on writing, 1 by minus 20 equal to 1 by u. Where is u? U is minus 50. All the things come in the left hand side. So minus 1 by 50 plus 1 by v, that we don't know. Now v should also come with a negative sign. Can you tell me why? Image is also on the left hand side. It is between f and c. So all the distances are measured from the pole to this, but rays are moving like this. Rays are moving like this forward, but image distance has to be measured from the pole to the image. So opposite direction. Distances measured opposite to the direction of incident light are taken negative. So it should be negative. Now there is no question of taking negative. All the values which are given, data, must be assigned with the plus or minus according to the situation. But what you are going to find out should not be assigned. They should come as it is. You should get the answer as it is, plus or minus. Okay, so what is v? We should get negative v. Okay, this minus 1 by 50, I will take it to the left hand side. It becomes plus 1 by 50. So what is 1 by v? 1 by v, I will keep it here only. Minus 1 by 50 will be taken here. So is equal to plus 1 by 50 minus 1 by 20. This 1 by 50 is taken here. So shall I take 100 as common? 100 centimeter. And everything is in centimeter. Don't worry. Answer is also in centimeter. Because all these are distances. I have not converted it into SI system. Suppose since all the things are distances, nothing else is involved, answer will be also in centimeter. So any unit is okay. 50 2 times and 20, okay, minus 5 times. So what is the answer? 1 by v is equal to 2 minus 5, that is minus 3 by 100. That implies v is equal to, so keep a habit of writing 1 by v always. Otherwise what we will do is, you will write 1 by v here, keep on writing this, 3 by 100 also here, you take 0.003 as the answer. But it is not the answer, it is 1 by v. What is v equal to? Minus 100 by 3 minus 33.33 centimeter. Does it lie between 20 and 40? F and C. F is 20, C is the 40, double. Yes, that is correct. So image is formed between F and C, minus 30. And minus is also okay because it is in this side. Image is diminished. Is it so? Yes. Suppose I take height of the object as, I will take height of the object. Say height of the object is, so h, that is what we take. H is the height of the object. Let me take it as some, say, some 10 centimeter I will take. Then what will be the height of the image? It should be lesser, let us see, and it is inverted below the principal axis. I want to calculate what is h dash. H dash by h. H is 10. Whether this is plus 10 or minus 10. Object is above the principal axis. So plus 10. Plus 10. H dash by h, height of the image by height of the object, is equal to minus sign v. V is negative, minus 33.33 minus 33.33 by u. U is 50 minus 50, and it is on the other side. Last time we have written u as minus 50. So what will be this answer? That is equal to this 10 will make this 5 times, and now we can divide. This minus will get cancelled with this minus, but one minus will remain. That is equal to minus 6.66 centimeters. Minus 6.66 centimeters, which is lesser than 10 centimeters. Minus sign indicates that it is inverted and it is below the principal axis. So everything goes very clear. So you must be very cool and very patiently you have to solve the problem. So everything has meaning. Negative sign says that it is inverted, and 6 centimeters, which is less than 10, says that it is diminished, and 33.33 says that it is between 20 and 40. It is between F and C. So everything is clear now. Now we will change the position. Okay, let us keep the object at C. Shall we get the image at C? Same sized, inverted. I think I can go a little faster now. How? Okay, I think I can do it here. Everything is same. Mirror, focal length 20, minus 20, because concave mirror on the other side. And height of the image, height of the object 10 centimeter, and object is kept at 50 centimeter, everything same. But object is not kept at 50 centimeter, it is kept at C, that means 40 centimeters. I'll take U is equal to minus 40, that means at C. You should get image at C, inverted, same sized. Okay, apply the formula. 1 by F is equal to 1 by U plus 1 by V. That implies 1 by focal length. Focal length we have taken already, it is 20 minus 20. 1 by U is plus 1 by U, plus 1 by U is negative, minus 40 at C is equal to 1 by F is equal to 1 by U, 1 by minus 40 plus 1 by V. So surely you know that V should be negative, and V should be same as 40, because object distance and image distance are same in this particular case. So we will solve this. Minus 1 by 20 plus 1 by 40 is equal to 1 by V. That implies 40 can be taken as common denominator. 1 by V equal to, I'll write this first, 40 can be taken as common denominator. Yes, 22 times minus 2 and 41 times plus 1. 1 by V is minus 1 by 40. That implies V is equal to minus 40 centimeters. So you know the meaning of each signal here. Minus on the same side, left hand side. 40 same as object distance, same sized here. So minus here, same sized. And if you calculate magnification, definitely you will get 1, because 40 by 40, it is 1. So size of the image then will be, if you substitute in the formula M is equal to H dash by H, V by U, you will get V by U as 40 by 40, then H dash by H gives H dash equal to H. So height of the image is also same as 10 centimeter. So that one case is over. Now let us keep the object between F and C. So where should you go now? I'll rub this. So I'll write the values again. And I'm taking this formula particularly to teach you how should you go along with sign conventions. That's the main intention. And then it becomes easy to solve the problems. This itself is a problem now. We are solving it. So focal length of the concave mirror is 20, but we have to give minus 20. Reason is focus comes in the same side as the incident rays, but you have to measure it in the opposite direction. And so then object distance, it should be between F and C. Center will be at 40 and focus will be at 20. So we will select some 30 centimeters. Object distance 30, minus 30 I will choose this side, and height of the object is 10 centimeter. We will analyze this. Where is the image? You know that image should be beyond C. Beyond C in the sense you should get more than 40 answer, right? So let us substitute. 1 by F is equal to 1 by V plus 1 by U. That implies. So you keep on writing. Hope you are writing along with me. That's very, very important. Otherwise these things are very useless. You must write it. 1 by F. 1 by F is 1 by minus 20 is equal to 1 by V, don't know, plus 1 by U. U is minus, so I'll write minus 1 by 30 directly. plus 1 by minus 30. Bring minus 1 by 30 to this side. Minus 1 by 20 plus 1 by 30 is equal to 1 by V. This comes to be plus when it comes to the left hand side. 1 by V remains here only. That implies I can take 60 common equal to 1 by V. 60 3 times minus 3, 32 times plus 2, minus 1 by 60. So minus 1 by 60 is 1 by V, implies V is equal to minus 60 centimeter. Everything is in centimeters. It is minus 60 centimeters, and 60 is definitely far away. And how much magnified it is? Anything away from C should be magnified. How much magnified it is? M is equal to H dash by H is equal to minus V by U. So that implies H dash we don't know. H, object distance above the principal axis, 10 centimeters is equal to minus, formula minus, image distance, that is also minus 60 by U. U is also minus 30. In between F and C, this one. Now this gets cancelled, and this is minus, this is 30, and H dash we want, this is 2 times, correct? And what is H dash? H dash is equal to 1 minus is remaining, minus 20 centimeters, which is double the size of the object. So image beyond C, but on the same side as the mirror, so minus of double the height, 20 than 10, is formed on the same side, beyond C. So this is also correct. So this is one type of image formation, right? So once you work out problems like this, you will definitely be able to remember all the things very clearly, because all these positions become very, very clear when you do all these things. Now come to this part of the image. What is this? Object is within the focus. So focal length of the mirror is, concave mirror is negative, minus 20 centimeters. I'll take object distance as minus 10 centimeters because it is within the focus, minus 10. Anything you can take, you can check it and you can do it in your house, you can get the answer. Height of the object is 10 centimeters. What is the position of the image? And you should come to the right hand side now. For the first time we should get an answer which is positive image distance, because if you divide this into Cartesian coordinates, if the image is formed here, from the pole you have to move it like this to measure the distance. And if you want to move like this, you are moving in the direction of incident light. Distances measured in the direction of incident light are taken positive. You should get image distance as positive. Okay, we will move. 1 by F equal to 1 by V plus 1 by U. Sir, why are you writing the formula again and again? Because I want you to write the formula again and again so that you will be acquainted with the formula perfectly when you write it many times. Okay, yeah. 1 by F equal to 1 by V plus 1 by U implies 1 by F minus 20 plus 1 by U. U is also negative, so I'll put the negative sign here only. Minus 10, which is within the focus, plus 1 by F is equal to 1 by F is equal to 1 by V plus 1 by U, 1 by 10. Yes, V we don't know. Minus sign came because U becomes negative, so already I put minus sign. F is negative, so we should get inside the mirror. So what is V? V should be positive now in this case. Minus 1 by 1 by 20. I'll bring this plus 1 by 10 here. This minus becomes plus when it comes to the other side, equal to 1 by V. That implies 20 common, and that is 1 by V. 20 common, 1s are, and 10 2s are. So what is 1 by V? 1 by V is equal to 2 minus 1 is 1 by 20, so that implies V is equal to 20 centimeters. So image is formed at a distance of 20 centimeters plus on the other side. That means you should, from the pole, you should move in the direction of incident light. Distances measured along the direction of incident light are taken positive. So you should move like this. That means inside the mirror, that is the image distance, V equal to 20 centimeters. What is magnification? It should be enlarged. Of course, we will come to know that it is enlarged. Image distance is 20, which is greater than the object distance. So magnification should be positive now. M is equal to H dash by H equal to minus V by U. That's what the formula says. Apply this formula. H dash, suppose you want to get the image height. Image height should be positive finally, because it is above the principal axis. H dash by H is the image distance, H object distance, that is plus 10 centimeters. Already we have taken object is of height 10 centimeters. It is plus above the principal axis, is equal to minus, in the formula, image distance, it is positive 20 by object distance, it is negative on the other side, that is minus 10. So H dash to be found out, H object distance above the principal axis 10 minus from the formula image distance 20 centimeter, it was in this direction, so no separate minus except this formula minus. But what about U, object distance? That is minus 10 because it is in the other side. Minus minus gets cancelled. What is H dash? 10 gets cancelled, only 20. So H dash is 20 centimeters, which is double the size of the object here. So enlarged virtual image distance is positive on the other side, is formed inside the mirror. So if you are perfect in all the sign conventions applying it, even if you go wrong, you will come to know that this has gone wrong. So this becomes very easy, and if you work out problems, how to apply the sign conventions. Now let us go to the last case, this one. A convex mirror forms always an image within the focus inside the mirror, and it is diminished. We will take a convex mirror. A convex mirror of focal length, same data we will take, 20 centimeter, and an object is kept at a distance of any distance you can use, there is no restriction here, say 10 centimeter, or I will take 5 centimeter in front of the convex mirror, and what else I can write? Where is the image? And what is the magnification? Magnification is how much? M is how much? Okay? Right. Now, how to take all these signs? If you incident a parallel rays on the convex mirror from left hand side, so that rays of light move along plus x-axis, they reflect in such a way that they appear to come from a point here. So focus comes on the right hand side, and if you divide this into coordinate system like this, focus comes on the right hand side. Focal length is plus. It is on the other side. Here, focus is here. It is positive. Object is on the left hand side, negative. What about image distance? How should be the answer? Positive. Can you tell me why? Because it is on this side. So image distance should be positive. Magnification positive. Why? Image is erect. Object is erect. So that should be positive. Okay. If the image is inverted, then only the magnification should be negative. And if image magnification is greater than 1, enlarged. Lesser than 1, diminished. Okay. Same formula, mirror formula, 1 by F equal to 1 by U plus 1 by V, or 1 by V plus 1 by U, anyway. Okay, apply this one here. 1 by F, 1 by 20 plus, it's a convex mirror. Don't by heart that convex mirror focal length is positive, convex mirror focal length is positive. Not like that. Just simply see why it is positive. If parallel rays are incident, they appear to come from the focus on the other side. That's why it is positive. So remember that case. 1 by F equal to 1 by U, 1 by minus 5 plus 1 by V. We don't know what is V. V should be positive finally. Bring this here, 1 by 20 plus 1 by 5, because this comes positive, is equal to 1 by V. So what is 1 by V? I think I can take common something like 50. 50 is better choice. 50, not 50. I'll take it as okay, 100 I'll take, no problem. I'll take 100 as a common denominator. 25 times 5 plus 5, 20 times 20. Right. That is 1 by V. 25 by 100 is 1 by V. See the method of solving. I always write 1 by V. I don't leave it at all, because I don't want to get carried away towards a wrong answer by not writing this 1 by v, because there is a chance that if you don't write 1 by v, there is a chance that I will write writing the answer this itself. That is not the answer, that is 1 by v. What is v? V is equal to 100 by 25, that is 4 centimeters. Now, is this within the focus? Because even inside the convex mirror it is formed within the focus. Yes, definitely. So, and image is formed plus, which is within the mirror. It is positive. Now, what about the magnification? Magnification is height of the image by height of the object. H dash is height of the image by height of the object. Okay, that is equal to minus v by u. We will apply this. So that implies h dash. Where is h dash? That has to be found out. You are not going to substitute this. H, height of the object, and I have taken it as 10 last time. Now also I will take it as 10 centimeters. It is above the principal axis, so plus 10 is equal to minus, formula minus v by u. V, image distance, we got it as positive 4. U was negative, that was minus 5. Right? So again, h dash to be found out. H 10 centimeter above the principal axis, positive. Formula negative, minus v positive 4, because we got it as 4, it is on this side. U on the other side, minus 5. So what is h dash? It should be diminished, it should be less than 10 centimeter. Let us see whether we get it or not. 5 2 times. And this minus will get cancelled. 2 4 times 8 centimeters, which is less than 10 centimeters, diminished image. Hope I am right? Yes. So, a diminished virtual image inside the mirror is formed, and it is erect above the principal axis. We got h dash positive, and it is not negative, otherwise it would have been inverted. Now it is erect, but it is diminished less than 10, it is formed within the mirror. So, this way, whenever you solve the problem, you should go along with the sign conventions. Theory part is very important, and you should try to connect it with the theory part, what you have studied, whether this is true, whether this is plus, whether this is minus. A little bit of patience is required, but this gives you a lot of confidence, because while writing the sign conventions, using the sign conventions in the problem, it is not the question of understanding the sign conventions, it is the experience of applying the sign conventions is very, very important. You may know all these 3 sign conventions very well. You have to take it as positive when you go along the direction of incident light. You know it, but how to apply it? That is only experience. Try to solve many problems regarding this. First, take some worked out problems from the book. Try to work it out yourself. Then compare it with the solution. And if you find any difficulty, of course, you can search the solution also, why it is taken negative and positive. Everything will be explained in the problem. And in this way, and then take unknown problems with some only answer key will be given, not steps will be given. Try to solve them. That is very important. So hope you will do some problems, you will solve it, you will get all the answers for that. So keep trying. All the best. Thank you.